Hello students, welcome to chapter 6. This is on elements, compounds and mixtures. I hope you will enjoy the topic. Welcome. Let's now start with the introduction. The universe which we live is made up of small building blocks called elements. When these elements come together, they create compounds. And when compounds come together, they form a mixture. Therefore, we can say that elements combine to form compounds, compounds combine to form mixtures. So, in this chapter, you will learn about elements and their symbols, compounds, mixtures, and how to separate mixtures. The knowledge you gain in this chapter will help you understand different ingredients and how to separate them in the things we encounter in our daily life. Let's now start with the elements and their symbols. You need to understand that matter is made up of substances which we call elements. Let's now ask ourselves, what is an element? An element is a chemical substance which cannot be broken down into simpler substances by any chemical means. Currently, there are about 118 elements, and most of them are found in nature. Some of them are made by scientists. As science and technology keeps expanding, we might find some new elements in the future. Examples of elements include sodium, potassium, hydrogen, gold, etc. Just like people, elements also have names, but they usually use special short names made of letters. These are called chemical symbols. These short names are just like codes, which makes it easy for scientists and students to talk about elements. Sometimes you might find that these codes don't look much like the regular names we use in English. For example, sodium's code is Na, coming from Latin. Also, the code for gold is Au, also coming from Latin. Generally, the rule for making these codes say that the first letter should always be capital. Of course, it is just like a secret language that scientists all over the world can use to talk about elements. Chemical symbols are written as per the rules of International Union of Pure and Applied Chemistry. We call it IUPAC. Okay, let's now see the criteria for assigning chemical symbols. Now, the following are the criteria which we use when assigning chemical symbols. The first rule is that an element may be represented by a chemical symbol that is derived from the first letter of its English name. From the table shown here, these are some of the elements with the chemical symbols derived from the first letter of their English name. For example, as you can see, boron has chemical symbol B, carbon C, chlorine F, hydrogen H, iodine, I, we just pick the first letter of their English name. As you can see from this table also, this is just the continuation of the previous table. So keep watching, you will understand. Sulfur, S, vanadium, V, yttrium, Y, and others of similar nature. Let's now see the second criterion. Sometimes the names of different elements start with the same first letter, such as cobalt, copper, calcium. So, if we use the same first letter, we will create confusion. To tell them apart, we use a second letter from their names, usually the second or third letter, along with the first letter to create their chemical symbols. This will help in differentiating the elements. Now, when we use this criteria, the first letter is always written as a capital letter, and the second letter is a small letter. For example, cobalt starts with a C, so its symbol is CO, with the first C being a capital and a small o. By using this criteria, it helps scientists and students to identify each element correctly without mixing with the other elements. From this table you see here, we have chemical symbols of some elements with the two letters from their English name. For example, aluminium, chemical symbol Al, argon, Ar, beryllium, Be, calcium, Ca, chlorine, Cl, cobalt, Co, and the others as you can see. Also, the table you see here is the continuation of the previous table. So we can see lithium, Li or Li, magnesium, Mg, manganese, Mn, neon, Ne, silicon, Si. So basically we use the first letter as capital and the second letter as small letter. Sometimes, instead of using English names, elements get their symbols from Latin words or names. It is just like using a secret code. For example, sodium is known as natrium in Latin. So, its chemical symbol is Na. This is usually done for few elements, and this helps scientists communicate more precisely about these elements. Now, the table below shows examples of elements with chemical symbols derived from their Latin names. As you can see, for example, we have antimony, Latin name stibbium, chemical symbol Sb. We have copper, Latin name cuprum, chemical symbol Cu, and others as you can see. This is just the continuation of the previous table. So as you can see, we have sodium. The Latin name is natrium. Chemical symbol is Na. We have tin. The Latin name is stannum, and the chemical symbol is Sn. We have tungsten. Latin name wolfram, and the chemical symbol W, as you can see. Okay, let's now start with the significance of chemical symbols. Why chemical symbols are used? They are important because they help people, especially chemists, in different ways. The first importance is that they make it easy to understand which elements are being talked about without having to remember the whole name. The second importance is that they allow chemists to write chemical equations in short form without using the full names of the elements. Another importance is that chemical symbols provide a quick way to know the name of the element. For example, if you see Cu, you know it is copper. Also, another importance is that chemical symbols help in differentiating one element from another, especially those elements which have similar letters. Let's now see about metals and non-metals. Generally, elements can be divided into two groups. These are metals and non-metals. Let's now start with the metals. Metals are elements like copper, sodium, zinc, aluminum, and iron. They have some properties that make them different from non-metals. Okay, we are now going to see about non-metals. Non-metals are elements like sulfur, carbon, and hydrogen. They have different characteristics compared to metals. Now we are going to see the characteristics of metals and non-metals. Scientists use a set of specific characteristics to differentiate between metals and non-metals. Okay, now as if you see in this video, we have properties of metals and non-metals. Elements can form metals, non-metals, and others, and we need to understand their properties, which are physical properties and chemical properties. Okay, as you can see, these are the physical properties which we need to understand for the metals. The first one is luster. Luster means shining. As you can see, gold, iron, they can shine. That is because of metals can shine. But when we go to non-metals, they are dull. They cannot shine or they do not shine. For example, if you check a ball, let's go to hardness. Okay, as you can hear now, if you try to cut the iron, you can't cut. Why? Because metals are hard. Let's try to cut that. As you can see, the rubber is easily cut because non-metals are very soft. Let's go to another property, which is malleability. We are going to carry out an activity. We have iron, nail, coal, aluminum, and lead. Let's try heating them. Do here. Yes, as you have seen here, for the iron nail and aluminum wire, once you hit them, they change the shape. But for the coal and lead, once you hit them, they break into pieces. That is because iron, nail, and aluminum are metals, while the coal and the lead are non-metals. Let's now check another property, which is ductility. What is ductility? Okay, ductility means that once you have the metal, you can bend it into small wires. For example, we can see we have aluminum wires, copper wires, iron wires, so they can bend. But once you try for a non-metal, if you bend, they break into pieces, as you can see. That is the property of ductility. Let's now go to sonority. Sonority means giving out sound. If you hit an iron bell, as you have heard, then it gives sound. That is what we mean by sonority. But once you hit something which is non-metal, no sound will be produced. Let's go to conduction of heat. If you are heating a metal, at the one end, the heat will be transferred to the other end directly. You can see the temperature is increasing up to the end. But that does not work for non-metals. It can't work that way. No heat can be transferred. As you can see, that is the property for non-metal. They do not conduct heat. But for the metals, heat transfers from one end to another. Let's go to another property, which is conduction of electricity. In this, we will carry out an activity, as you can see from the screen. Now, we will have different tools to use. Let's check the observation from those materials. Iron nail, if you put there, the bulb lights on. That is a good conductor of electricity. What about sulfur? Nothing happens. Then it is a bad conductor of electricity. Let's check coal piece. Nothing happens. That is a bad conductor. Let's go to copper wire. Yes, it has. You can see it gives light. That is a good conductor of electricity. Yeah, I hope you have seen this. So all of those are the physical properties of metals and non-metals. We have some exceptions. For example, sodium and potassium are metals but are soft. As you can see, they are soft, you can cut them. Let's see another exception. Another exception is for iron. Iron, copper, gold are solid, while mercury is liquid. It is liquid but still a metal. Non-metals, for example, iodine can shine though it is a non-metal, and diamond is a hardest substance. However, it is still a non-metal. Therefore, when we are classifying substances into metal and non-metal, properties, physical properties only are not sufficient. We need also to consider chemical properties. Hope you have enjoyed. Okay, now let's see the differences between metals and non-metals in this table. Of course, it is similar to the ones we have seen in the previous video. Here is just a highlight. You can see, and I hope you will understand because we have already covered those in the video. Just keep reading slowly. No differences. Also, in this table, we see the continuation of differences between metals and non-metals. It is just similar to what we have seen in the previous video. So I urge you just to keep reading it, and I hope you will understand everything as we have already explained them thoroughly. Keep reading. Let's now discuss about the exceptions. While we can classify elements as metals or non-metals based on their physical properties, there are few cases where there are some exceptions. Okay, let's think of diamond and graphite. These are forms of carbon, which is a non-metal. However, diamond has a high melting point and it doesn't conduct electricity, and it's very hard. On the other hand, graphite, which is another form of carbon, is a non-metal, but it is an excellent conductor of heat and electricity. Therefore, as we have seen from the previous slides, carbon breaks the usual metals and non-metals rule in these forms. They behave just like metals. Let's now see another exception for sodium, potassium, and mercury. Usually, most metals are solid at room temperature, but there are some exceptions. Hence, elements like sodium and potassium are very light metals with extremely low melting and boiling points. These elements can even become liquid or melt at temperatures you even encounter in your kitchen at low temperature. Another exception is mercury, which is usually in liquid form at room temperature. This is different from other metals which are usually solid. Therefore, even though we have general rules for classifying elements as metals or non-metals, there are some exceptions or elements that don't fit the rule. Therefore, these substances have their special properties that make them different from the normal metals and non-metals. Hence, you need to know their chemical properties, which you will learn in your advanced classes.